Okay, so I decided to do one last problem. In this problem, problem number 5, a conveyor belt is wrapped around circle O and forms a right angle at P, the point outside the circle. So our goal is to find the length of the belt if circle O has a radius of 6. So I want you to understand that this is what the belt is doing. It's wrapped around this. Okay, so we know that the radius is 6, and we know that these two things are tangents. So if we connect a tangent to the center, we have created right angles here. And it told us that this was a right angle. And so we know we have 3 right angles. It's a quadrilateral. That would have to be a right angle, and since the radius is 6, these two sides would be 6, and then you have obviously a rectangle. At least it will be a square. Opposite sides will be congruent. So we know that this part that we need, we have found to be 12. We need to figure out what this part, and that would be an arc length. Remember that this right here is 90, so this is 90. So this red arc length will have an arc measure of 270 degrees. Okay, so we're trying to figure out what this red length would be. To figure that out, we're going to say 270 is to 360 as what that arc length is to the circumference, and that would be 2 pi r, which would be 12 pi. When you actually do the arithmetic here, you get 3,240 pi equals 360x, and then that is 9 pi. So the belt, when you're looking for the belt length, will be this 9 pi plus the 6 and the 6. So it'll be 9 pi plus 12 millimeters, because it is, the measurement is in millimeters. If you do that as an approximation, you get 40.274. So I like that problem. You had to know that tangents and radii make right angles. They told you this was a right angle, and then that made that. The fourth angle of the quadrilateral also right. So awesome problem.